3.5 Symbolic Arguments. Alright, you do not have to memorize these. You don't have to memorize them. You can totally have them written out. I don't have them on the scrap paper, the tables that I have, but you can have them available, like on a note card or something. I do allow that if this were a face-to-face class. I actually put these on the board for you. So you are allowed to look at them for the test. Alright, a symbolic argument consists of premises and a conclusion. It is called symbolic argument because we generally write it in symbolic form to determine its validity. An argument is valid when its conclusion necessarily follows from a given set of premises. An argument is valid or a fallacy when the conclusion does not necessarily follow from the given set of premises. So a valid argument, there's 4 types of valid arguments, and you notice it's just P and Q for most of them. One of them has R. So law of detachment is P if then Q. P, those 3 dots, remember they mean therefore. They mean therefore. Q, law of contraposition, so P if then Q, negation Q, therefore negation P. Law of syllogism, syllogism, P if then Q, Q if then R, therefore P if then R. Disjunctive syllogism is P or Q, negation P, therefore Q. And now we have invalid arguments. So invalid arguments are also known as fallacies. So fallacy of the converse. If you're an English buff, you might kind of already know what that means, but not in the sense of symbols. So fallacy of the converse is P if then Q, Q, therefore P. Fallacy of the inverse is P if then Q, negation P, therefore negation Q. So we're going to, how to determine if something's valid, you write it in symbolic form. You compare the form to one of the known forms, so one of the arguments. If there are no known forms, then to compare it to, then we do step 3. If the argument contains 2 premises, write a conditional statement of the form premise 1 and premise 2, if then conclusion. Construct a truth table, and if the answer column of the truth table has all truths, the statement is a tautology, and the argument is valid. So for it to be valid, it needs to be a tautology. And you'll see an example of that in literally example 4. Yeah, example 4, we use a truth table, and we're going to be using step 3. So to determine the validity of the argument with the truth table, we're not going to use the truth table for example 1 because it follows one of the arguments. So let's just take that away. So our P, if you have enough reward points. So you have enough reward points. That's P. Our connective, if then, you get a free flight. So that's Q. So you see how we drop down to the next sentence? Right, so our P was reward points. Our Q was free flight. So you see how we drop down to the next line? It's like if you pressed enter on your spacebar, that means it's literally the next line in the argument. So you do not get a free flight. So free flight, that's Q, but since it says not, we put the little squiggly. And the therefore means the line. We have you do not have enough reward points, so reward points, that was P, but since we have not, we put the little squiggly. So we have P if then Q, negation Q, therefore negation P. Let's see if that matches any of our arguments. So go ahead and take a look, see if it matches any of our arguments. See, do you see it? Alright, awesome. It's law of syllogism. My bad. Law of contraposition. I was looking at the wrong word because I don't have it up. Law of contraposition. So law of contraposition, it looks just like this. So this is valid. And why? It's because it's the law of contraposition. All right, determine whether it's valid or invalid. So our first is you are on Instagram. So P is you are on Instagram. We have a connective, if then. Our next subject is you see my pictures. So our P, I bet I keep doing that. our Q is you see our pictures. Oh, sorry, see my pictures. All right, our next is you see my pictures. So that just means P, or excuse me, Q. We have a new subject here. We have a new subject. You see I have a dog. So we have an R. Therefore, if you are on Instagram, so that's our P, then you know I have a dog. So R. So let's bring this out into symbols. If you are on Instagram, so P, our connective is if then. You see my pictures, so that's Q. Next line. If you see my pictures, then you know I have a dog, that's R. We have our therefore. You are on Instagram, so that's P. Then you know I have a dog, so that's R. Let's see if that matches any of our laws. It does. It's a law of syllogism. We have P if then Q, Q if then R, therefore P if then R. So this is valid. And why? It's because the law of syllogism. All right, let's identify common fallacies. So this is going to be a fallacy, but let's prove it. If it is snowing, then we put salt in the driveway. We put salt in the driveway, therefore it is snowing. That sounds totally valid, right? It does. If you think about it, like that sounds valid. But this example is going to show you not to assume anything and break it down into symbols. Seriously, read it a couple times. It sounds valid. You're like, okay, it's snowing. We put salt in the driveway. They put salt in the driveway, so duh, it's snowing. Think about that, though. So let's break this down into symbols. It is snowing. That's P. Then we have our connective, if then. We put salt on the driveway. So that's our Q. So we put salt on driveway. All right, next we put salt on driveway. That represents Q. Therefore, it is snowing. So it is snowing was P. So let's break this down into symbols. We have P, if then Q. Next sentence, we put salt in the driveway, so Q. Therefore, it is snowing P. So P, if then Q, Q, therefore P. Let's see. That is fallacy of the converse. So it is invalid. It's invalid because it's fallacy of the converse. Oh, we're going to save example 4 to last, okay? Because we're actually not going to fill it out piece by piece. I'm just going to switch to a screen and show you. This is definitely, example 4 is definitely not tested on. It's never tested on, but I want to show you how to bring this out into using that step 3. Remember when we talked about it, step 3 right here? I want to talk more about that. But we'll save that for last. Let's do example 5. So, determine a logical conclusion. Sometimes we're going to be given a statement and we need to determine a logical conclusion that actually follows laws. So, as we always do, determine P, Q, and if there's an R. So, the camel is a dromedary. So, we say P, that camel is a dromedary. We have our connective. The camel has one hump. So, that's our Q. All right, then we have a period. Let's just keep going, though. The camel does not have one hump. So camel has one hump. That's Q, but remember we have the little squiggly because it says not, and we have a therefore. So first sentence, we have P if then Q. And you see the period. The period... My bad. Let me get a different color. The period just means next line. So next line, we have the camel does not have one hump, so negation Q. We want to know, therefore, what? So what we're going to do is look at our laws, our valid laws, and figure out let's figure out what the ending is. Let's figure out what the ending is. So we have P if then Q, negation Q. So P if then Q, negation Q, that's a law of contraposition. Since it follows the law of contraposition, we know it's P if then Q, negation Q. We know the ending is negation P. So to sum this up, to form a conclusion, we need to negate P. So we would say, therefore, the camel is not a dromedary. So that would be our logical conclusion. There's quite a bit of these on the test. Use your laws. All right, let's go back to the example 4. The first thing we're going to do before I switch over, we're actually going to break this down into P's and Q's and R's. And I'm going to show you how to fill out the truth table with just showing you, like literally just showing you. I'm not going to fill it out. All right, so if my cell phone company is Verizon, so P is cell company is Verizon, then I can call you free of charge. So that's our Q, call free of charge. If I can call you free of charge, so that's Q, nothing's changed there, or I can send you a text message. That's a new object, that's a new subject, so that's R. So send a text message. So I'm just going to say send a text. I can send you a text, so that's our R, or my cell phone company is Verizon. That's P. Therefore, my cell phone company is Verizon. So that's P. So let's write this into symbols. We have our connective of if-then. So my cell phone company is Verizon. That represents P. I can call you free of charge. That's Q. Next line. I can call you free of charge. So Q. We have our connective of or. I can send you a text message. So that's R. Next line. I can send you a text message. Our connective of or. My cell phone company is Verizon. That's P. We have our therefore, so line. Therefore, my cell phone company is Verizon. That's P. That does not match any laws. It's crazy, right? So we can't actually put that into any laws. So that's where you would use a truth table. So now going back to step 3, if you can't compare it to any laws, you're going to set it up as an argument. So it's going to be premise 1 and premise 2 and premise 3. You can keep going there, and then if-then conclusion. So how we would set this up, we would say bracket, because there's a bunch of stuff going on here. So bracket. Every time in between a line, we put an and. So and then the end will always be if-then. So I'll help you out with that. We have P if then Q and Q or R. And so each sentence, each line, when you write it out, you put an and between it. Then we have R or P. Since that's the end of the top, we close it out. Then we have our if then P. So to write this in our truth table, we would have P if then Q and P or Q or R and R or P. Close out the bracket if then regular P. So first, you would do what's inside the brackets. So I would do this first, this second, this third. So each parentheses, you do that first. Now we need to bring the whole bracket together. So if we wanted to get this connective, we know to get the middle connective on opposite sides, it's 2 and 1. That gives us 4. For this connective, if we wanted that connective on opposite sides of that connective, so opposite sides of that connective, we know that this is on the opposite side, so 3. That's going to give us, our next number is 5. So what brought together the whole left side? So on the left side, what brought it together was 4. So 4 and 3 give us 5. Next, we do the single one of P, so that's the 6th column, and our last column is the 7th, which is our connective. So we probably know that 6, because 6 is the whole right side, will give us 7. And then the left side, the entire left side, the last thing we did for the left side was column 5. So column 5 and 6 give us 7. Let me show you what that looks like. So this is what our truth table would look like. So we do P if then Q, then we do Q or R, and then we do R or P. We bring it together with our connectives. We write down P. So 7, our answer column, it has a false. It actually has 2 of them. Since it has 2 false, we would say it's a fallacy.